1943. American P-38 pilots were dying, not from enemy bullets, but because their own fighter planes would violently shake apart and lose control whenever they tried to dive at combat speeds, turning what should have been their greatest advantage into a death sentence. Then, one engineer did something so simple, so stupid, that every aerodynamics expert said it would never work. Yet it transformed the P-38 from a flying coffin into one of the most feared aircraft in the Pacific. What was this impossible trick that broke all the rules of physics and saved thousands of American lives? Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The year was 1942, and something was terribly wrong in the skies over the Pacific Ocean. American forces were fighting their way across tiny islands, one bloody beach at a time, trying to push back the Japanese Empire that had struck Pearl Harbor just months before. Every island meant more lives lost. Every mile gained cost blood and treasure. And in the air above these desperate battles, American pilots were dying in a way that made no sense at all. The United States was supposed to have the best of everything. American factories were churning out ships, tanks, and planes faster than any nation on Earth. President Roosevelt had promised to turn America into the arsenal of democracy, and the production numbers proved he meant it. Assembly lines in Detroit that once made family cars now built bombers. Women who had never worked outside their homes were riveting wings onto fighters. The whole country had transformed into one giant war machine, and everyone believed that American ingenuity and industrial might would win the day. But there was a problem that all the factories and all the determination in the world could not seem to fix. The problem had a name, and it flew on twin engines with a distinctive twin-boom tail. They called it the P-38 Lightning. On paper, the Lightning was supposed to be a war winner. Lockheed's engineers had designed something that looked like it came from the future. Two powerful Allison engines mounted on long booms. A central cockpit pod between them. Sleek, fast, and heavily armed with cannons and machine guns clustered in the nose. It could fly higher and faster than almost anything the Japanese had. It could carry more ammunition and stay in the air longer. Test pilots said it felt like strapping yourself to a rocket. Military planners looked at the specifications and smiled. This was the plane that would sweep the Japanese Zero fighters from the sky. But then the combat reports started coming back from the Pacific, and the smiles disappeared. Pilots were reporting something that sounded impossible. When they pushed the Lightning into a high-speed dive to attack enemy planes below them or to escape from a fight going bad, the aircraft would start to shake. Not just a little vibration, but violent shuddering that rattled their teeth and blurred their vision. The control stick would go stiff, fighting against them like it was locked in concrete. Then the nose would tuck down on its own, pushing the dive even steeper, even faster. Pilots would haul back on the stick with both hands, using all their strength, and nothing would happen. The Lightning would just keep diving, faster and faster, shaking harder and harder, until something broke. Sometimes what broke was a wing. Sometimes the tail booms tore away. Sometimes the whole airplane just came apart in the air like a toy smashed by an angry child. And the pilot, if he was lucky enough and low enough to bail out, would parachute down and watch his plane tumble into the ocean in pieces. If he was not lucky, he rode it all the way down. The worst part was that enemy fighters were not even shooting at them when this happened. Japanese pilots would watch in confusion as American planes simply destroyed themselves. It was like watching someone trip over their own feet and fall off a cliff. Back at Lockheed's massive factory in Burbank, California, the reports landed on desks like bombs. Engineers gathered in worried clusters, spreading out technical drawings that covered entire tables. They measured and calculated. They built models and tested them in wind tunnels, watching smoke curl over miniature wings. And slowly, terribly, they began to understand what was happening. The problem had a scientific name: compressibility stall. When the lightning dove fast enough, the air flowing over its wings started to behave in strange ways. As the plane approached the speed of sound, invisible shock waves formed on the wings. These shock waves disrupted the smooth flow of air that kept the plane flying. The wings lost their lift. The controls stopped working. Physics itself seemed to betray the aircraft. Every expert who looked at the problem said the same thing. The only way to fix it was to completely redesign the wing. Maybe redesign the whole airplane. That would take years. It would cost millions of dollars. It would mean stopping production, retooling factories, retraining workers. And in the meantime, the war would go on without the lightning. Pilots would keep flying older, slower planes. More Americans would die. The military brass in Washington were losing patience. Some generals wanted to cancel the whole program and put the money into different fighters. Orders for new Lightnings were being cut. The plane that was supposed to win the air war was becoming an expensive embarrassment. In a corner of the Burbank factory, one engineer was not sleeping well. He spent his days looking at the same data everyone else saw, the same wind tunnel results, the same impossible physics. But at night, he stayed late, staring at drawings of the Lightning's wings pinned to his office wall. Everyone said you could not fix the problem without changing the wing. Everyone said the shock waves could not be controlled. Everyone said it was impossible. But this engineer had a different question forming in his mind. What if you did not try to prevent the shock waves? What if you did not try to make them go away? What if, instead, you just found a way to make the plane fly right even with the shock waves there? It was a crazy thought. It went against everything the textbooks said. But pilots were dying, and crazy was starting to look better than impossible. The engineer sat alone in his office long after everyone else had gone home, surrounded by papers covered in numbers and sketches. Outside the windows, the California night was dark and quiet, but inside his head, an idea was growing that would not leave him alone. He kept coming back to the same thought that seemed so obvious it felt stupid, yet so radical that no one had tried it. If the shock waves on the wing could not be stopped, maybe they did not need to be stopped. Maybe they just needed to be managed. He pulled out a fresh sheet of paper and started drawing. Not the wing itself, but something underneath it, something small, something that could change the airflow just enough to let the pilot pull out of a dive. His pencil moved quickly, sketching flat plates that could deploy from the bottom of the wing at high speed. They would stick down into the airstream like tiny speed brakes, disrupting the shockwave pattern and forcing air to flow differently over the wing surface. It was ugly. It was inelegant. It added drag to a plane that was supposed to be fast. But maybe, just maybe, it would let pilots regain control when they needed it most. The next morning, he brought his sketches to the chief engineer's office. The reaction was exactly what he expected. The chief looked at the drawings, frowned, and shook his head. Adding more parts to solve a high-speed problem? Creating drag to fix something caused by going too fast? It made no sense. The wind tunnel data did not support it. The theory did not predict it would work. And even if it somehow did work, how would they test it without killing a pilot? The chief pushed the papers back across the desk. Interesting idea, he said, but they needed to focus on realistic solutions. But the engineer could not let it go. He talked to a few friends in the machine shop, guys who knew how to build things quickly without asking too many questions. Together, after hours, they pulled parts from damaged P-38s waiting for repair. They cut metal plates and fabricated hinges. They built a simple mechanism that could deploy the flaps using hydraulic pressure. It was rough work, done with hand tools and determination, but after 3 weeks of secret late-night labor, they had a working prototype ready to install. The hard part was finding a test pilot willing to try it. Most pilots had heard the horror stories about lightnings that would not pull out of dives. They knew men who had died that way. But there was one pilot, a test flyer named Tony, who had been pushing the Lightning to its limits for months, carefully noting exactly when and how the controls locked up. He had felt the plane betray him more than once and barely recovered. When the engineer showed him the modified wing with its crude flaps bolted underneath, Tony studied it for a long time. Then he asked one simple question: "Do you really think this will work?" The engineer was honest. He said he did not know for sure. The theory said it shouldn't work, but the math also said pilots should be able to pull out of dives, and they could not. So maybe the theory was missing something. Tony looked at the flaps again, then at the engineer's face, then back at the flaps. Finally, he nodded. "When do we fly?" The test happened on a clear morning with almost no wind. A small group gathered near the runway. Just the engineer, a few mechanics, and one supervisor who had reluctantly agreed to look the other way. Tony climbed into the modified Lightning and started the engines. The twin Allisons roared to life with their distinctive deep rumble. He taxied out and took off into the bright blue California sky. Everyone on the ground watched as the Lightning climbed higher and higher until it was just a glint of silver in the sunlight. Then the glint tipped over and started down. Tony was diving now, pushing the throttles forward, accelerating into the speed range where the controls would normally freeze. The watchers held their breath. This was the moment when Lightnings tore themselves apart. This was when pilots died. The Lightning kept diving, faster and steeper. Then something changed. The nose pulled up, smoothly, normally. The plane swooped out of the dive in a graceful arc and climbed back into the sky. No shaking, no loss of control, no pieces falling off. Just a fighter plane doing exactly what its pilot told it to do. Tony brought the Lightning back around and landed. Before the plane even stopped rolling, the engineer was running toward it. Tony climbed out of the cockpit with a strange expression on his face, somewhere between shock and joy. He kept saying the same thing over and over. "It worked! It actually worked! I don't understand how, but it worked!" They made him explain everything 3 times. When he deployed the flaps at high speed, he felt the normal shuddering start, but then it smoothed out almost immediately. The control stick, which should have been locked solid, moved freely in his hands. He pulled back and the nose came up just like it was supposed to. He tried it again and again during the test flight, diving and recovering, and every single time, the flaps did their job. The Lightning that had been a death trap suddenly flew like a dream. Word spread through the factory faster than fire. Engineers who had dismissed the idea came to see the modified plane. They walked around it, touching the flaps, trying to understand how something so simple could solve such a complex problem. Some were excited. Others were skeptical, saying it must have been luck, that it would not work in real combat conditions. But the military liaison who heard about the test had a different reaction. He made one phone call to the Pacific, talked to squadron commanders who were desperate for anything that might save their pilots, and came back with orders. Install the flaps on every Lightning. Do it now. Production moved faster than anyone thought possible. Within weeks, modified P-38 Lightnings started rolling off the assembly line with the dive recovery flaps already installed. The flaps were no longer crude prototypes bolted on by hand in the middle of the night. They were proper production parts, precisely machined and tested. But they still looked strange hanging underneath those sleek wings like afterthoughts. Engineers who had spent years studying aerodynamics in universities looked at them and shook their heads. The design was ugly. It violated principles they had learned from textbooks. It added weight and complexity to an aircraft that was already complicated enough. But none of that mattered anymore, because the flaps worked. And that changed everything. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. The first modified Lightnings reached combat squadrons in the Pacific Theater in early 1943. Pilots gathered around the new planes with a mixture of hope and suspicion. They had all heard stories about friends who had died in lightnings that wouldn't pull out of dives. Some of them had experienced the terror themselves, felt their controls lock up, felt the plane shake itself toward destruction while they pulled helplessly on the stick. They had learned not to dive too steeply, not to go too fast, which meant giving up the lightning's greatest advantage. They had learned to be careful with an airplane that was supposed to make them dangerous. The squadron briefings were simple and direct. The new flaps would deploy automatically at high speed, or pilots could activate them manually with a switch in the cockpit. When things went wrong in a dive, flip the switch. The engineers promised it would work. Most pilots nodded and tried to believe it, but belief came hard when you had already watched planes fall from the sky in pieces. Then they started flying combat missions with the modified Lightnings, and everything changed. The first pilot to use the flaps in actual combat was a lieutenant from Iowa who got jumped by 3 Japanese Zeros while escorting bombers. He dove away from the ambush, pushing his Lightning faster than he had ever dared before, and the Zeros followed him down. In an old Lightning, he would have been trapped, unable to pull out, forced to either slow down and get shot or keep diving until something broke. But he flipped the switch for the dive flaps and felt them deploy. The shaking stopped. The controls responded. He pulled back on the stick and the nose came up smoothly, and he was climbing again while the Zeros were still trying to follow his dive. He came back around and shot down 2 of them before the third one fled. When he landed and climbed out of his cockpit, his hands were still shaking, but not from fear. From the realization that his airplane had just saved his life instead of trying to kill him. Stories like that spread through every Lightning squadron in the Pacific. Pilots who had been flying carefully, holding back, suddenly pushed their planes to the edge and beyond. They dove out of the sun onto enemy formations, attacked and escaped before the Japanese could react. Used their speed the way the Lightning was always meant to be used. The aircraft that had been nearly worthless in a dogfight became a predator. When Japanese pilots tried to follow Lightnings into high-speed dives, the Americans would pull out smoothly, while the Zeros had to level off or risk losing control themselves. It was like having a superpower that only worked for you. The kill ratio started climbing. Squadrons that had been struggling to break even were suddenly racking up victories. The Lightning went from being the plane that pilots tried to avoid flying to the plane they requested. Men who had written goodbye letters before missions, certain they would die in planes that would shake apart beneath them, now wrote home about how the Lightning could do things no other fighter could match. They talked about diving away from entire enemy squadrons and living to tell about it. They talked about confidence, about trust, about finally having an airplane that did what it was supposed to do. Back in Burbank, the engineer who had sketched those first crude flaps on a piece of paper late at night watched the combat reports flow in. Each report was a pilot who came home instead of dying. Each victory was proof that impossible just meant nobody had figured it out yet. Other engineers who had dismissed his idea now studied it carefully, trying to understand exactly why it worked. The truth was that even with all their testing and analysis, nobody fully understood the precise aerodynamics of how those flaps disrupted the shock waves. The theory lagged behind the reality. The flaps worked better than the math predicted they should. Sometimes the best engineering was not about perfect understanding, but about trying things and being willing to look stupid if you were wrong. The transformation went beyond just the Lightning itself. Across American aviation, engineers started questioning other rules they had been taught. If dive flaps that should not work could save an entire aircraft program, what other impossible problems had simple solutions that nobody had tried? The rigid thinking that said you had to understand everything before you built anything gave way to a more practical approach. Build it, test it, fix what breaks, and if it works, then figure out why later. It was messy and inelegant, but it won wars. In the Pacific, pilots gave their modified Lightnings nicknames. They called them fork-tailed devils, a name the Japanese had supposedly used, and they wore it with pride. They painted elaborate nose art on the central pods and kept count of their kills on the fuselage. The lightning that had almost been canceled, that had almost been written off as unfixable, became one of the most feared fighters in the theater. It was the plane that hunted Admiral Yamamoto and shot him down over the jungle. It was the plane that flew higher and faster and farther than anything else America had. And it was the plane that proved you could break every rule in the book as long as you brought your pilots home alive. By the time the war ended in August 1945, the P-38 Lightning had flown more than 130,000 combat missions across 2 oceans and 3 continents. The dive recovery flaps that had started as a desperate midnight experiment in a California factory had become standard equipment on every Lightning that rolled off the production line. Thousands of pilots came home alive because of those small metal plates bolted under the wings. Thousands more never knew how close they had come to flying an aircraft that would have killed them. The Lightning's reputation had been completely transformed from a dangerous liability into a legendary war machine, and all because one engineer refused to accept that impossible meant impossible. When the factories finally stopped building Lightnings and the assembly lines went quiet, the engineer went back to designing other aircraft. If he was the man who would later be known as Kelly Johnson, then his career was just beginning. He would go on to create the U-2 spy plane that flew higher than anyone thought possible. He would design the SR-71 Blackbird, which flew so fast that it could outrun missiles and still hold speed records more than 50 years later. He would become a legend in aviation, the man who built planes that redefined what aircraft could do. But he never forgot the lesson of those dive recovery flaps. He never forgot that the best solution was often the one everyone said would not work. The Lightning itself lived on after the war in surprising ways. Some were sold as surplus and ended up in strange places, flying cargo in South America or racing at air shows. Others were carefully preserved in museums, their twin booms and central pods still looking like something from a science fiction story. And if you looked closely at the wings on those museum planes, you could still see the dive recovery flaps, those ugly little additions that saved so many lives. Visitors would walk past them without really noticing, not understanding that those simple flaps represented a moment when everything changed. Years later, after he had designed planes that flew 3 times the speed of sound, an aircraft that could photograph enemy territory from 70,000 feet, the engineer would sometimes talk about the Lightning and its flaps. He would tell young engineers that the hardest part of the job was not doing the math or understanding the physics. The hardest part was having the courage to try something when everyone with authority and expertise told you it would fail. He would talk about how innovation did not come from following the textbooks perfectly, but from knowing when the textbooks were wrong. He would say that you had to respect the rules and the science, but you also had to be willing to break them when lives were on the line. After the war, some of the German and Japanese engineers who had designed enemy aircraft came to America to work. They were brilliant men who had built incredible machines under terrible conditions with limited resources. But many of them struggled to understand how American aviation had advanced so quickly. They had been trained in rigid academic traditions where theory came first and testing came second. The idea of bolting crude flaps onto a wing just to see if they worked without first having a complete mathematical understanding of why they should work seemed backwards to them. They wanted to understand completely before they built anything. But the American approach had been different. Build it fast, test it hard, fix what breaks, and save the complete understanding for later. It was messy, and it wasted some time and resources, but it also meant solutions came faster when they were desperately needed. The contrast between the approaches was stark. German engineers had designed beautiful, elegant aircraft based on perfect theoretical understanding. But when those planes had problems, fixing them took forever because every solution had to be proven theoretically before it could be tested. American engineers designed planes that were sometimes crude and inelegant, but when problems appeared, they tried fixes immediately. If the fix worked, they used it and figured out why later. It was the difference between being right and being fast, and in wartime, fast mattered more. At an air show many years after the war, a restored P-38 Lightning sat gleaming in the sun. Families walked around it, children pointing at the twin booms and asking why it looked so different from other planes. An elderly man stood near the wing, one hand resting gently on the metal. He had flown Lightnings in the Pacific, had used those dive recovery flaps in combat more times than he could count, had brought his plane home safely when by all rights he should have died in a dive he could not pull out of. A young engineering student noticed him and asked if he had flown in the war. When the old pilot nodded, the student pointed to the flaps under the wing and asked how the engineers knew the flaps would work. The old pilot smiled. They did not know, he said. They just knew that pilots were dying and something had to be tried. The student looked confused, so the pilot explained it differently. Sometimes you cannot wait until you understand everything perfectly. Sometimes you have to try the crazy idea and see what happens. The worst thing that could occur was that it would not work, and you would try something else. But if you never tried at all because you were waiting for perfect certainty, then people kept dying while you waited. The student thought about that for a while, looking at the flaps that had seemed so simple from the outside, but represented something much bigger. Finally, he asked what the most important thing was that the engineer learned from the whole experience. The old pilot looked up at the Lightning, its twin booms rising into the sky, and thought about all the pilots who came home because someone refused to accept impossible as an answer. He said the lesson was simple. Impossible just means nobody has figured it out yet, and sometimes the person who figures it out is not the smartest one in the room or the one with the most degrees. Sometimes it is just the one who refuses to give up and is willing to look foolish trying things that should not work. Because every once in a while, they do work, and when they do, everything changes. Up next, you've got two more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.